we're going to pour some Babbitt in the blocks and also pour our main caps up in preparation of line boring and installing our crankshaft. In front of us is a bunch of tools, just different hardware that I'm going to use to cut, snip, pour, tighten, mess around with basically. But our purpose here this morning is to deal with pouring the main caps. The main caps have bearing in it, have Babbitt in it. They are tinned, so we'll melt this Babbitt out. The block here is one that I had previously poured and cut, but found that I had a small defect in the center main cap that I didn't like. So I'm going to knock all the Babbitt out of the block. You can chisel it out. It's just a mechanical bond. Chisel it out and drill out all the oil holes or the anchor holes. Get everything cleaned up and prepare it so I can install molds to pour the Babbitt. And these molds are being made by a fella out in Colorado, Gene French. I made my own molds, but they're basically what he does. You can buy them from him or you can make them yourself. But anyhow, we're going to go through the process of getting the caps cleaned up, tinning the caps, pouring Babbitt in the caps, installing the molds and pouring the cap. Get the block prepared, cleaned up, ready to go so we can install our molds on it and pour our Babbitt. Talking about caps, you want to make sure that you have a decent set of caps. A lot of them have been filed down. You need to make sure, especially if you're putting in a new scat crank that's full size, if this has been filed down quite a bit, you're going to end up with some pretty thin Babbitt in here. So you want to make sure that it will indeed work for your application. Caps are tinned and it's a chemical bond. And this cap here, we're going to go through, we're going to mount out all the caps and prepare them all. But this cap's kind of interesting in that it's really kind of makes a clunky sound. And I guarantee you when we melt out this Babbitt, we're going to see areas where they're just, where it's going to pull right away from the metal, and areas that it's going to be, there's going to be a Babbitt film left on it. And it's just because didn't get a good tin job. And this is a cap that the Babbitt's been removed out of. And it's got a nice sharp ring to it. And when we're done pouring the cap and it's cooled down to room temperature, it should make a nice sharp ring. That's an easy way of knowing whether you got a good bond. Babbitt. Right, I mean no tin right there. I mean what's there is just coming right off. There's absolutely not a very good job of tin. Now here you can see hopefully this shows up in the camera, but right through this area, right in here, I'm looking at bare steel, but I see Babbitt that's stained on the part. Again, right in here, there's no tinning action. The Babbitt just wasn't bonded to it. When you burn this Babbitt out of a cap that's got a good tin job on it, you won't see any steel. There'll actually be a thin coat of Babbitt stuck bonded. After melting the Babbitt out, I've just ran it through my blast cabinet just to clean it up somewhat. Good thing to look at. I talked about making sure that it wasn't filed down so much, but also, especially on the rear mains, make sure that the holes are round. A lot of times these caps have been filed out to adjust, slide them back a little bit to take up the thrust in it. So make sure that you do pick out caps that are decent. But I'm just going to come in here and clean off everything. So I've just taken my high speed and I've ran it across there. That's knocking off any of the grit that I may have bedded in there went through my blast cabinet. And okay, so I ran my wire brush on the grinder on it and cleaned it all up. The next thing I'm going to do is take a little carburetor cleaner. All right, we're going to tin the bearing first. There's a lot of different products that you can use. You can buy solder that is lead free, has pure tin with a little antimony in it. You can use it. There's some products called Tin Tight, tinning butter. You can get that from Eastwood's. Here's another product, Tin Easy. It's a powder that you can use. Or my personal choice is soldering salts that I get from a company called Superior Flux. I just use Babbitt and the soldering salts as a means of getting a tin. Cap will turn colors, turn blue, turn black, and then it'll start clearing up. And I got my IR gun here. We'll just see, but I think that occurs somewhere around 550, 600 degrees. You need to get it hot enough to get the tin to work. Just take a little bit of Babbitt and just melt it down in there. And get my wire brush that I got some soldering salts on. Do this in a well-ventilated spot because that flux probably isn't too good for you to breathe. And I like to leave my caps a little on the goopy side. So I'll come back in here and just wipe some Babbitt on it. And I just dress it around. You can see the flux is floating. You can see how it's the Babbitt. I can wipe it, bring it up to the edge, and it just drops back down into the bottom. All right, so we've tinned all of our caps up. They've cooled down, and I'm going to get rid of the flux or the soldering salt residue, get that all cleaned up. I just use a little carburetor cleaner and a wire brush. So we've got the flux. Started off with something with goopy, okay, and you can see, like I said, I leave my Babbitt a little goopy in here. I don't wipe it out in the tinning process. Some people wipe them out, some people leave them goopy. This is just my preference is to leave it a little goopy. So and we're ready to pour that cap in a mold and heat it back up again and pour Babbitt. I'm going to start building the molds onto our caps. And here in Oklahoma we have a thing called humidity big time, so my molds, when I'm done with them, to keep them from rusting up so bad, I sprayed a little WD-40 on them, and I want to wash all that off right now with a little carburetor cleaner. Okay, we're going to build up our molds in preparation of pouring the Babbitt into them. I've already cleaned the caps with carburetor cleaner, and I sprayed down my molds to get rid of the excess WD-40, get the oil off of it. The mold for the rear main, and the rear main is probably the most critical one. They're all critical, but the rear main has thrust poured on it, so my dams, end plates, I machined out a relief in here. So when the cap goes in place, it provides an area for the thrust surface to wrap around the edge of the cap, and hopefully we bond it to the cap and get a nice pour on it. So I want to start building up the rear main. And I want to take a look and make sure that I got the cap into the mold correctly, and that the plate, that I don't have a big gap. If I had, for being a little overly cautious, I use a product called Anti-Heat. It's available from Eastwood, and it's just a, you can use it just to dam up, or so the Babbitt doesn't sneak its way out of here when you heat it. Dammed up. So I've just went around the edge of the cap where it joins the dam, and just applied a little bit of that anti-heat. That's number 3. We'll get the other ones built and we'll be ready to pour. We built all 3 of the molds, got them sealed up with a little putty to keep it from leaking out. I'm going to make sure that my sprue hole, my little indexing, is all lined up. I just prop them up to where I can get a torch. I'm just using a small 50,000 BTU weed burner and get it elevated enough to where I can get my heat up underneath it. It's starting to wet up. I can look down in there. So I'm getting close to temperature. 500. We poured the rascal, and we got temperatures well above 550 degrees, and right now I'm looking at it and it's 675. So I've got it up high enough temperature where the tinning process that we did, now that we poured Babbitt into it, if you poured it too cold, it wouldn't bond, even though you had a good tin job. It's temperature critical, so you need to experiment around with what works best for you, but I find that those are kind of the numbers that work well for me, and they end up giving us the end result is we get a good job. This is a chemical bond. I don't have to worry about removing anything, getting anything out of the way. It's just a matter of the top, no problem. And I want to make sure that I got a good bond, no gaps, and we do. And again on this side, same thing. Looking to see that we got a little tin left beyond where the Babbitt poured and no gaps, no edges in it. So we got a pretty decent cap there. And you can hear how it's ringing, and once it cools down to room temperature, it'll even ring more than that. So I'm going to cut my sprue off. Little hacksaw. I'm going to go over to my belt sander, sand off all the bent holes, get it to where it's flush with the rest of the cap, taking care not to be grinding on the cap, but just to get all this cleaned up out of the way. So I ran my belt sander, kind of knocked off the high parts of it, and I got that little bit left of the sprue. I'm going to just grind it. Just knocked it off. That'll all cut out of there as I run the cutter through it. And we're about ready to take that cap and put it on a block, make sure that it sits flush and square. Then you have to take it over and do a little work on the 600, 400 sandpaper and kind of flatten it out. Don't want it to rock on the block. And we're ready. We'll do the other two caps the same way. So my theory is that if we don't have a good bond, this cap won't resonate, won't ring. Cap with no Babbitt in it. Nice, good, sharp ring. And our cap that we just finished up. Nice, sharp ring. Okay. I want to remove the Babbitt out of this block. Again, this is a block that I poured previously, and so if you notice, the Babbitt looks pretty good, and it really was, other than I had a defect in the second cap, middle cap that showed up at the very tail end of cutting this out. And I thought, well, it's just a minor pinhole. It's about the size of a pencil lead, fine pencil lead. And the more I thought about it, the more it aggravated me. And after I'd completely finished cutting all the oil grooves and everything, getting it cleaned up, I decided, it's a do-over. So the Babbitt, like I said, in the block is strictly a mechanical bond. So get the Babbitt out of the block, and you can see the three in the rear main. There's three anchor holes that we want to get cleaned out. I just use a drill motor and a drill bit. That piece of Babbitt came out pretty much as a chunk. But you can see the tits that pour into the anchor hole, and when I hit it from this side hard enough, it just pulled it on out of there. Sometimes it does. Most generally, you got to drill them out. Cleaned out. I'm going to take a little flapper wheel and come in here and clean off the saddles, and then I'll wash everything down with a little carburetor cleaner and blow it out good and dry. We'll come back and we'll plug the oil holes with some of our heat shield, so the Babbitt won't, when I pour it, if I don't have the hole plugged, it goes right into your tennis shoe, and it doesn't feel very good. Don't ask me how I know that. Anyhow. Again, this is a mechanical bond, not a chemical bond, so still like to get it clean. And then we'll take some of our putty or whatever you want to call it and plug up these holes. Now some people use wood dowel. Some people prefer using chalk. I just go ahead and plug them up with this, and I know the location of the holes, and I just drill them out when I get done. But I just pack that full. I'll wipe out the excess, and I'll come and kind of clean that up after it sets just a bit. Got a little carburetor cleaner on it. I'm just wiping off the excess that I had around. And I want to make sure that none of the little pieces made it up into the extra hole. So I'll blow them out. And I'm just taking a last look at it. Another thing, I don't want to have anything on the edges of the block because I'm going to put my dams of the mold up against that and clamp them into place. And I don't want to have a chunk of anything on there that keeps me from developing a leak and let it leak out. So we're ready to put the molds on. So I'm using the same mold plate that I used for pouring the thrust on the third main cap, but I don't need a thrust. I don't pour a thrust on this surface. Henry Ford didn't. Some people do. I don't. So the mold, I've changed out the dams to where it's just a flat plate. And I want to make sure that I do have the plates up against the block. And I do. And when I get ready to pour, just as a little extra precaution, I don't have any, don't really have the room to put that anti-heat or that blue compound. It's kind of tough to do that. So I find if I just take a very light pressure, not enough to distort it. Again, I have an index on the plate and an index on the little sprue that I'll use to pour with, and make sure that I get it lined up correctly. The front, because of the timing gear, crankshaft gear, I have to modify one where it's got a little bit of a radius in it so it fits. So again, the front mold I've radiused off so it would fit into the block. It's a mechanical bond. We've got to get it hot enough to where the Babbitt flows into the anchor holes, and after we've poured it, while it's still rather warm, as soon as it gets just a little bit below 400, I'll start dismantling this, cut that sprue out of the way, get it ground flat, and then I'm going to peen that bearing into it. There's a couple of different methods of doing that, and I'll show you that here in a moment, but it's important that you peen that bearing. It helps swell up those anchors. It assures you that you've got a good fit into the bearing. The center one's pretty easy to do. There's no extra mass of material. It's easy to heat around, and we're going to bring this up to in the 400-degree range to make sure we got it warm enough to flow. The front one, we've got a lot of mass of material and we really can't get to it, so it takes a little more concentration on this edge as opposed to over on this side, which doesn't have the extra material. So kind of have to concentrate here. The goal is to try to get it up even temperature on both sides. The rear, fairly straightforward on the inside, but we do have all that extra material that hangs out the back, the saddle if you would, that hangs out the back of the block. So you have to make sure that we concentrate down on this area and get it up to temperature as we go along. So generally I start for the center. Doesn't make any difference. I just have it pour the center, and then it's either this one or that one. It doesn't matter. So before I start to pour, I want to take just a moment and talk about peening the Babbitt. Things are going to get real busy when I've got this poured. As soon as it cools down to where I can handle it and it's solidified, I'm going to disassemble the mold, get it out of the way, get the sprue cut off, get it ground down, and then peen it. K.R. Wilson built a tool that kind of looks like this, serration, a round meat tenderizer kind of thing, and you just simply drop it down into the Babbitt. It happens to be about the size of what I'm pouring to, and you just smack it around, and it does a decent job. But one of the fellows on the forum talked about using an air impact, and I thought, well, I'll try that. And I really have liked how that works. It seems to do a little better job of peening it in. And basically this is just one of those air chisels, air impacts. And I just took one of their chisels and removed quite a bit of material and put a small radius on the end of it. And I've been using this at real low pressure, and it really does a nice job of peening everything out. So this is the process I'm going to use. This is a process that you'll see. You can even find these. I made this, K.R. Wilson, for peening, and you just sit in there and just bang it. But you need to do that while it's still good and warm. A little bit about temperatures. I have a Fluke IR that I can direct read the temperatures that I'm achieving. You can go to the welding shops and pick up, they have little sticks, different temperatures. I'm going to shoot for, like I said, around 400 degrees on the block. So I've got it hot enough to where my Babbitt will pour in. And Babbitt temperatures, everybody has a little different rule of thumb. I like to run mine, anywhere around 850. So I'm running right about just a shed under 900 degrees right now. As I pour down, it'll get a little hotter because it'll have less material in it. So I may add another chunk or two to it, but don't want to get it too hot. So I'm going to preheat the block up. We'll start with the middle one. We'll preheat it up, get it up to 400 degrees, get the dross cleaned off. And dross is this, it's tin, it's oxidized, and you want to make sure that you get that out of the way. You don't want that to pour down in your Babbitt. And another thing that old timers talk about is always make sure that you get your Babbitt stirred up. And so through the process of getting that cleaned up to where I can pour, it'll stir around, and then I'll dump it. And like I said, as soon as it cools down enough to where I can disassemble the mold, then we'll finish that bearing before I pour a different bearing. wiggles and giggles. Yeah, it's over 400 there now. Get down to about 375 or something like that. I'll start disassembling this thing and we'll see where we're at. So I'm just going to watch it for a little bit and see where my temperatures are. Okay, so I seem to be set up here. 350, 360. So I'm going to start taking this one apart. Yeah. Looks like a pretty decent pour so far. And then there's, like I said, we have the two processes. We could come in here with a K.R. Wilson and pound on it. And while it probably works well, I think this is a little better way of doing it. And it's just down on low pressure. I'm just going to start here in the middle. And work my way up the edges. Be careful not to get to the very top, but I want to make sure that I get up high enough to where I've peened it into the edge and I'm peening it into those anchor holes. And while it's still warm, it's soft. Now's the time to file off the excess pour. So after I've got it peened and I've filed off the excess, I want to make sure, I'm going to take a visual look, and I'm looking at the radiuses on the pour. Make sure that I don't have any voids, that I'm good and bonded up to it across the top, same way on both sides. And basically that's a forward bearing, and I'm pretty happy with it. I'll clean it up a little bit with some sandpaper later when we're fitting the cap. Make sure that everything's good and flat and that the cap doesn't rock. But we'll move on here and do another bearing. I would just point out that this is how I do it. There's a lot of different ways and a lot of different opinions on what the correct method is or procedure, peening versus not peening, peening with an air impact, peening with a K.R. Wilson. You know, there's just, everybody has their own opinion. And this is not necessarily geared for you guys that know how to pour Babbitt, because most of the guys that know how to pour Babbitt, they're dead and gone. You know, this is kind of an art that's lost. It's just went away because of modern engines have inserts. But this is the way that I skin the cat. Your mileage may vary, but I'm pretty dadgum successful. I've probably got about, well, I don't know, 80, I'm probably 80, 90 engines out there, and I've had two failures. One was a main cap. Early on, didn't do a very good job of getting tinned. While the cap looked tinned, I just didn't have a good bond, and it split on me and consequently got to knocking within about 4,000 miles. So we fixed that. Another problem that I had was with just one of my good friends. We Babbitt the engine, put it all together and ran it down the road, and he ran it with so much advanced timing and out of oil that it failed. Well, it was my engine, it was my failure. We went in and fixed it for him because he is a friend. But this is how I skin the cat, and it seems to be working out quite well for me. Your mileage may vary.